Okay, in 10.3 we're looking at ellipses. So the way we get an ellipse is if we have 2 points. These are foci, okay? And if we look at every point whose sum of the distances is constant. So basically, if you think about putting these 2 push pins in a wall, and I'm going to tie a string to the push pin, and instead of letting it just droop, right, we're going to make it taut. And we put a pencil right in the piece of string, and you can draw all the way around. The shape that you're going to get is going to be an ellipse. And then if we move the string maybe to the lower side, you'd get the other half. And basically what this is going to form, all the points that you draw with that pencil is going to sketch out an ellipse. So each point on the circle is going to be x comma y, and the string stays the same. So d1 plus d2 is going to remain constant. Okay, and then I guess I better label my foci. Those are the 2 foci points. So when you get your ellipse, I'm going to draw it again because it has a lot of characteristics that go along with it. Besides the foci, what we have the center, okay? And if you draw a segment through the center to the furthest parts of the ellipse, that's going to be your major axis. And then if we go perpendicular to that, to the shortest sides, that's going to be your minor axis. The points where those axes hit the ellipse on the major axis, those will be the vertices. And then on the minor axis, those will be what are called covertices. And then here's the center in there. All right, okay, so standard form of an equation of ellipse, if the center is at hk, just like a circle, these are going to be subtracted, and parabolas, right? Subtracted from the x and y values. So it's going to be x minus h squared. And then we're going to have y minus k squared, but they're going to be divided by something. One of them is going to be divided by a squared, and the other one is going to be divided by b squared. A is always larger than b, but they're both positive. So b is going to be between 0 and a. And then the larger one is going to tell you if you have a horizontal major axis or a vertical. So if the bigger number is underneath the x stuff, you're going to have a horizontal ellipse. And if the bigger number is under the y stuff, then you have a vertical ellipse. So this one is going to be x minus h squared, but it'll be over the smaller number. And then plus y minus k squared over the bigger one is equal to 1. Okay, and that a value, that's going to give you the length of the major axis. So the major axis is 2 times a. So the distance from the center to a vertex is going to be a. Then the distance from the center to a covertex, that's going to be a b value. So the whole minor axis has a length of 2b. Okay. Oh, and then the foci. The foci are c units from the center, and c squared is going to equal a squared minus b squared. So that length will come from those numbers. All right, let's look at one of these. We're going to put it into standard form and figure out all the information that we need about it to graph it. So looking at this equation, I can see that I don't have a linear x or y term. So what that means is this is going to be centered at the origin, and I don't have to complete the square for x and y. Okay, so we'll see other ones where you do have to do that. For this one, though, I just want to get the 1 on both sides. So what I'm going to, a 1 on one side. So what I'm going to do is divide everything by 16. On the left, we're going to have x squared over 1, and then the y squared will be over 4, and then this is 16 over 16, so there's my 1. Now, based on that information and what we just talked about, go ahead and put into the Edpuzzle, is this going to have a horizontal major axis or a vertical? It's going to be vertical because the larger number is beneath y squared as opposed to x squared. So this is going to be vertical. The a value is going to be 2 because that is equal to 2 squared. The b value is going to be 1 because there's 1 squared underneath the x squared. And then we can plot some points from here. So we just said the center is at 0, 0. So I'm going to start there. And because this is a vertical ellipse, I'm going to go up and down 2 units. So I'm going to put points 2 units above and 2 units below the center. Okay. And then with the b value, we're going to go left and right. So the larger distance, remember, goes vertically because the larger number is underneath the y piece. Okay, and then I can sketch my ellipse from there. Okay, the last thing I'd want to put on here are the foci. So my c squared is equal to a squared, which was the 4, minus b squared is 1. So my c value is going to be the square root of 3, which is about 1.7-ish. So if I look at my ellipse, the foci are going to be on the major axis. Okay, they go towards the vertices, but not quite that far out. So in this case, I'm going to go 1.7 units towards those vertices. All right, that is it for the graph. Let's see example 2. So now we're given some information about one. We're going to write the standard form and then sketch it. So here are the foci, -2, 2, go the right way, and 4, 2. Because the foci are left and right of each other instead of vertical like this one, this is going to be a horizontal ellipse. And then the major axis has a length of 10. So I know my major axis is 2 times a, and that's got to equal to 10. So my a value is going to be 5. Well, a value is 5. If I have the foci, I can actually get the center from that because our center has to be halfway in between any combination of points. It's halfway in between the co-vertices, halfway in between the foci, halfway in between the vertices. So the center of this ellipse is going to be halfway in between those. So that's at 0, 2. And that also gives me my c value. The foci are each 2 units away from the center. So that's going to be c, and I can figure out what the b value is. So c squared equals a squared minus b squared. So this is 4 equals 25 minus something. And my b squared is going to come out to be 16. So because my b value is 4, that is going to be how far away my co-vertices are from the center. And that's going to be in the vertical direction. So I'm going to go up 4 units from the center and down 4 units. This almost looks like it's going to be vertical, but I haven't actually graphed my vertices yet, right? For the a value of 5, I need to make sure to go 5 units in the horizontal direction from the center. There we go. So here's the co-vertices. Oh, I'm sorry. Here are the vertices, and these guys would be the co-vertices, and then I can sketch this. It's something like that. That's not super round, but we'll live. Okay. So I need to write the formula now, right? My center was at 0, 2, so that's going to be x minus 0 squared over, and now am I going to put this over the a squared or the b squared? Go ahead and put that into the Edpuzzle. I'm going to put x squared over the a squared, so that's going to go over 25, because this is a horizontal ellipse, so I want the a value to go under x, plus y minus 2, because that's the y coordinate of the center. I'm going to divide that by b squared, and this whole thing is equal to 1. So there's the standard form of this ellipse. For example 3, we've got a conic that's in general form. They're telling me it's an ellipse, so okay, I'll believe them. We're not going to graph this one. We're going to go ahead and write it into standard form so we can get all of these qualities out from that form. So this one we are going to have to complete the square for both x and y. So I'm going to go ahead and group the x's together, 16x squared and then minus 32x. Group the y stuff together, 25y squared minus 50y. And then I'm going to put my constant on the other side, so I'm going to subtract 16. To be able to complete the square, I need an a value of 1, which means the leading coefficient, or the coefficient of my x squared term, needs to be 1. So I'm going to factor a 16 out of both of these terms. This will be 16 times x squared minus 2x, and I'm going to leave a little bit of a gap so I can complete the square. Same kind of thing for y. I need to factor a 25 out of both of those terms, so that a value will be 1, then that'll be y squared minus 2y, and I'll leave a little bit of the space there. I haven't actually changed anything yet, I've just done a little bit of factoring. So now I need to complete the square. So take half of 2 and square it. I'm going to add 1. Same kind of thing here, a half of 2 squared. But what happens is this 1 is getting multiplied by 16. So I didn't just add 1, I added 16. So I need to make sure to add 16 to the other side. Same kind of thing for y. I didn't just add 1. This time I added 25. So I need to add 25 to the right hand side. Alright, so let's rewrite this in so that these trinomials are factored. That'll be x minus 1 squared and y minus 1 squared. And on the right hand side, that's going to simplify to 25. I want to get a 1 on that right side, so I'm going to divide all 3 pieces by 25. And this will be x minus 1 squared divided by, so I want to have this divided by something that's squared. Well, instead of multiplying by 16 and dividing by 25, what I can do is divide by 25/16. And the reason we can do that is because instead of multiplying by the reciprocal, right, you can think of this as the reciprocal of 25/16. So I'm dividing by this instead of multiplying by the reciprocal. I'm going to get cut off, so better jump to the next video before I continue. Okay, so I inverted this fraction. It was times 16 and divided by 25. I'm still dividing by 25, but now I'm dividing that by 16. So really it's equivalent. I've just rewritten it with that fraction in the denominator because this is something squared, and that's going to be able to give me either my a or my b value. So let's see what the next one is. This y minus 1. Those 25s are just going to cancel, so this is just going to be over 1, and on the right hand side we're going to have 1. So let me rewrite this as a square. So this is x minus 1 squared, and 25 over 16 is just 5/4 squared. And this, of course, is 1 squared is equal to 1. So because 5/4 is bigger than 1, our a value is going to be the 5/4. And our b value will be the 1. The center will be at 1, 1, because those are the two numbers that are being subtracted from x and from y. And this is going to be a horizontal ellipse because the a value, the bigger number, is below the x stuff. So then our vertices will be 5/4 of a unit in the horizontal direction. So I'm going to change the x coordinate of the center by 5/4. So if I add 5/4 to 4/4, that'll be 9/4, 1. And if I subtract 5/4 from 1, or from 4/4, that'll be negative 1/4. So those would be the coordinates of the vertices. Okay. Here's all the things that we want. They ask for the center, the vertices, and then the foci. So because I have the a and the b, we can figure out what the c value is. C squared is equal to, a squared was the 25/16. e squared was 1, but if I write that in terms of sixteenths and subtract 25 minus 16 is 9. And therefore our c value is going to be the square root of those, so that'll be 3/4. So same kind of thing for the we're not finding co-vertices. For the foci, I want to go in the horizontal direction because it's the same direction as the vertices. So from 1, 1, I'm going to add 3/4 again to that x coordinate. So 4/4 plus 3/4 will be 7/4. And 1 minus 3/4 would be 1/4. And that's good because these shouldn't be as far out as the vertices are. The vertices are further away. So that's the last piece. Those are the foci. And that's everything they want. Okay. One more equation in general form. We're going to find all of the stuff and we're going to graph it. So let's start by grouping x stuff together. Group y stuff together and move any constants to the right. Okay. I want to factor a 2 out of the x stuff and leave a gap. Factor a 4 out of the y stuff and leave a spot. And then let's complete the square for both of these. Half of 2 squared is 1. I didn't just add 1 though, because the 1 does get multiplied by 2, so really I added 2. So I'm going to do the same thing to the right. And then for y, same thing, half of 2 is 1, but I didn't just add 1 because it gets multiplied by 4, I actually added 4. So let me rewrite. This will be 2 times x minus 1 squared, and 4 times y plus 1 squared is now equal to 8, and I'm going to divide all 3 pieces by 8 to get a 1 on the right hand side. Let me scroll up a little. Okay. So the x minus 1 squared, 2 eighths will simplify to 1/4. 4 eighths will simplify to 1/2. And 8 eighths simplifies to 1. So there's our standard form. Let's get all the stuff out of there. Center is at 1, -1. Our a value is 2. Our b value is the square root of 2. Okay, so because this is 2 squared, and the square root of 2 is our b. And this is going to be another horizontal ellipse because the bigger number is under the x stuff. So in the horizontal direction, I'm going to go 2 units away. In the vertical direction, I'm going to go root 2 units away. That's about 1.4. And then let's get the foci. So c squared is equal to a squared minus b squared. So our c values are also at root 2. So 1.4 in the horizontal direction. And then you can sketch these. It looks something like that. So one other thing I want to mention about ellipses is what's called the eccentricity. And it basically tells you if you have like a fat ellipse or a skinny one, or kind of gives you the ovalness of the ellipse. So what we want to look at is the ratio of c over a. That gives us the eccentricity. So if e is small, what's going to happen is, like if the c value is small compared to the a value, the foci are going to be close to the center as opposed to the a value, which would give us the vertices. If the foci are closer to the center as compared to the vertices, what's going to happen is it's going to be a more circular ellipse. Maybe look something like that. If your e value is close to 1, that means that your c value is close to your a. These are close in number, so maybe the a values are still here, but the c values are way closer to that. that's going to give us a skinnier, this kind of looks like a hot dog. I don't know what that looks like. But it's going to give you a skinnier ellipse, and it's going to be more elongated. So we can look at the E value to kind of help us tell how oval it's going to be, more circular or more elongated. All right, that is it for 10.3.